Electron affinity and its changes. This is today's lesson. In this lesson, we are going to learn definition of electron affinity change along a column, and electron affinity change along a period. So let's go to the detail. The first point is definition of electron affinity. Let's see the matter. Suppose this is an atom, this is its nucleus, and this is its outermost shell. Let us consider here there is an electron. When this electron is added to the outermost shell of this atom, then we get this anion, uninegative ion, and during this some amount of energy is produced. This energy is called electron affinity, which is directly opposite of the ionization energy. Here just one atom is showed, but it is impossible to deal with one atom. So 1 mole atom is considered. That is, here 1 mole atoms, gaseous atoms, here 1 mole electrons. Then 1 mole uninegative ions. At that time, the energy produced is called electron affinity. Here, affinity of nucleus to this electron, attraction of nucleus to this electron, which is termed as electron affinity. Let's see definition of electron affinity. When 1 mole electron is added to 1 mole gaseous neutral atoms to form 1 mole uninegative ions, then the energy released is called electron affinity. The amount of energy released when 1 mole electrons is added to 1 mole neutral gaseous atoms to form 1 mole uninegative ions is called electron affinity. Electron affinity is related to atomic size or atomic radius. Let's see the matter. Let us discuss electron affinity with atomic size. Suppose this is an atom which is a bit smaller in size. Another atom which is bigger in size. Here electron which is attracted by this nucleus. Here this is the distance. Let us consider here 1 electron which is attracted by this nucleus. Here this is the distance. We know electron is negatively charged and nucleus is positively charged. So attraction between nucleus and electron. In this case, shorter distance, high attraction. But in the second case, longer distance, low attraction. That is, for smaller size atoms, electron affinity is higher, and for the bigger size atoms, electron affinity is lower. The smaller the size of atoms, the higher the electron affinity, or the bigger the size of atoms, the lower the electron affinity. Simply, we can say that when atomic sizes increase, distance between nucleus and this electron increases, and as a result, attraction force decreases. That is, electron affinity decreases. The bigger the size of atoms, the lower the electron affinity. Let's move on to the next point. Now the point is change of electron affinity along a column. Let us consider a column 17, fluorine, chlorine, bromine, iodine, astatine, tennessine. Here, electron affinity of chlorine, electron chloride ion. Electron affinity is here Ea. Electron affinity is denoted by EEA, energy of electron affinity. Here this is minus 349 kilojoule per mole. This is electron affinity of chlorine. Electron affinity of bromine is bromide ion. This is minus 325 kilojoule per mole. That is, electron affinity decreases from top to bottom along a column. We know along a column atomic sizes increase, and as a result electron affinity decreases. For chlorine, electron affinity is 349 kilojoule per mole, and for bromine this is lower, which is 325 kilojoule per mole. Here minus sign is used because this is a kind of exothermic process. Electron is produced here. That is why minus sign is used. Electron affinity is denoted by EEA, energy of electron affinity, which decreases along a column in the periodic table. Let's move on to the next point. Now the point is electron affinity change along a period. Let us consider two elements that belong to one period, that is oxygen and then fluorine. In the periodic table, fluorine belongs to right side of oxygen. So we can say that oxygen is a bit bigger in size than fluorine. So electron affinity of fluorine should be higher than oxygen. Let's see. Here oxygen 1 electron, oxygen minus, uni negative ion. Here electron affinity of oxygen is minus 141 kilojoule per mole. Here we see electron affinity of oxygen is 141 kilojoule per mole. So according to normal trend, electron affinity of fluorine should be higher. Let's see. fluorine electron fluoride ion. Here, electron affinity of fluoride ion is minus 328 kilojoule per mole. That is, electron affinity of fluorine is higher than oxygen because atomic size of fluorine is smaller than oxygen. That is why electron affinity of fluorine is higher than oxygen. For oxygen, this is 141 kilojoule per mole, but for fluorine, this is 328 kilojoule per mole. Let us conclude electron affinity decreases along a column and it increases along a period because along a column atomic sizes increase and along a period atomic sizes decrease. When atomic sizes decrease, attraction between nucleus and incoming electron increases because distance decreases. This is normal trend of electron affinity. This is all about electron affinity and its changes. No more today. Thank you very much.